Are we ready to start? Right. Hello, I'm Nadal. This is going to be a hands-on session, so how many of you have your laptop out? Okay. Who doesn't have a laptop, or who will not be able to code, or at least follow along? Anybody? Okay, you? Anybody else? Okay. So please feel free to interrupt me at any point, because the whole purpose of this session is to actually have a conversation with you guys so you understand what's happening and what's going on. So to start, like I said, I'm Nadal, and my story is that I am a front-end developer. So that might sound a little scary that I'm talking about databases, given that my experience is HTML, CSS, JavaScript. Well, for the last long while, I've been using other databases, and after a threshold of pain, where I'd be woken up at 2 a.m. to debug why my app had crashed, and after searching around for endless hours, finding out that it was the bottleneck of my database, I was like, you know what? I don't care if there's database experts out there who say that they've built this or that. If they're experts, they should have created something easier. So I stopped doing front-end development because I did not like doing DevOps or system administration or any of that back-end stuff. And I decided, you know what? I'm going to make a database that just works. But that's coming from somebody who has no experience in databases. So I am, well, how many people here are an expert in databases? Okay, nobody. Wonderful, we're all equal here. I am not an expert, you guys are not an expert, but guess what? We're going to work towards making a better solution for all of us. So I came up with Gun. Gun is a JavaScript. Gun is a JavaScript database that is a graph database that runs in the browser and synchronizes peer-to-peer with all your other devices. So I'm going to give a quick demo of that just so you can see what's going on. If people go to gunjs.herokuapp.com, you can see that I can type stuff, and when I hit enter, it syncs to the other page. I can spam it with, let me scroll down over here. I can spam it with some updates, blah, 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 blah. Okay, so as I type, the updates get sent to the other tab as fast as the connection between them. Oh, thank you for the compliments. I better be careful what people type on the screen. But thank you for the compliments. So those two apps, the JSON editor is less than 100 lines of HTML, CSS, and JavaScript in its entirety. Okay, so it's very, very tiny. The To-Do app is about 13 or 14 lines of JavaScript. So it's less than 40 lines of HTML, CSS, and JavaScript. Now, you might, who's familiar with Heroku here? Okay. So Heroku is a service which you can deploy your apps to, and that's already sounding pretty scary. But something funny about Heroku is that every 15 minutes, they kill your app. They wipe it. They delete it. Because for the free version, if nobody's using the website, they're just going to turn it off. So that becomes a problem, where if you have data and you want that data to persist, I'm going to change tabs. If you want that data to persist, then you have to save the data someplace. But then if you have to save the data someplace, not only do you have Heroku that you're deploying to, you then also have to have this database service that you're using, or you have to run your own database. And then you have to make sure that that website or that service is up and available and that it's not crashing. And generally speaking, it just becomes a pain because all we want to do is build this awesome to-do app or some silly kitten app, right? But everything crashes or things are too complicated and annoying. So I'm going to show you, so that was like an example of the sync that it can do in real time. So kind of Google Docs style collaboration. I'm going to show you some more interesting demos that you don't have to run on Heroku. In this case, I'm going to run. So the reason why I'm using Windows is I assumed that if anybody else was running Windows, I could help them out with it. But everything else is much easier to work with in like Ubuntu or probably on a Mac. But just want to make sure I was at the lowest common denominator. So I have Gun installed on my computer directly, and we'll get to that in a bit. I want to demonstrate something really neat. So I'm going to run the server, which is, if I can even read it. There we go. So the server's coming online. Sorry, not the Gun server. You don't need a Gun server, but I'm going to just show you that most databases do use a server. I'm going to show how I'm going to invert the model. So then when I reload this page, I have the app that you saw in production locally on my machine. And if I open it up in another tab, you'll see that then when I hit add, that it updates, right? I can then add some something, and it also syncs with some gibberish. But now I'm going to do something horrible, terrible, monstrous. I'm going to kill the server. So the server's dead. I just deleted it. Or I just turned it off. But I'm going to do something worse than, well, OK, first step. I killed the server, and I'm going to turn the server back online. If I reload the pages, everything is going to still be there. OK, so I killed the server, turned it back online. Things are still there. That's like by default something a database should give you. But now the interesting thing. I'm going to kill the server. And the server has the data saved up there, or in this case, it's just on my machine. I'm going to delete that data. The data is stored right here. I'm going to delete it. OK, so now I can't get that data back. And as proof of this, when I come here, you'll see that if I try and type in here, it won't synchronize because there's no, the server is also being a relay agent to send the messages. That's not necessary, but it's just for demonstration purposes. So neither of these clients are getting the update. And we're going to write conflicting values. So I write AAAA in here and BBB over there. Okay? Now proof that the server is offline, when I hit refresh, page not available. Oh no, what has happened? The server is down. We've wiped the data from the server and completely deleted it. We made conflicting updates on two separate peers, and we refresh their page and their data is lost, right? We're out of luck, right? Well, no. If I turn the server back online and I refresh these, the data is going to come back. And not only is it going to come back, but it agrees upon the most recent update. What on earth just happened? This is something you will not see anywhere else in any other database. I have wiped out the only master database, the only server. I've deleted all the data, and I made conflicting updates, yet everything's still there. What's going on? Well, the secret of the sauce is that the database is entirely written in JavaScript, which is a very, very scary idea. Okay? But because it's written in JavaScript, it is running in the browser. So because it's running in the browser, even if I destroy the server, there's still a backup on all the peers that are connected, for all the users. So I'm able to survive failure because I have a backup. So that is just an introduction of how you can very easily not have to worry about pain or problems or any of the server-side stuff, because even if your servers crash, even if they go offline, you don't have to worry about it. Your data is safe. Your data is OK. All right, now that that introduction is there, I'm going to take some quick questions just to test how well I've done in explaining the idea, and then we're going to move into the actual kind of workshop side of the equation. Any questions? Yes?
How is the integrity of the database preserved?
OK, so he asked, how is the integrity of the data preserved? So this is quickly jumping into the technical sides of Gun, and I'll try and summarize that Gun uses a conflict resolution algorithm that is completely deterministic. So that means every single peer, whether it's the server, whether it's the browser, or another, or if you have Gun running on multiple servers, are all running the same algorithm. So that way, whenever they get updates, they transform it through the same conflict resolution algorithm, and they then, because of that algorithm, converge to the same data. So the integrity is preserved across peers in a completely decentralized setting. If people are interested, I'm willing to go into the more technical side of that. But if people also just want to jump on board and start coding stuff, we can go that direction too. So any other questions? Yes.
Can the data be deleted at any time? Like, petrol, you don't want.
So can the data be permanently deleted? OK. So because I'm building Gun to guarantee the safety of your data, it actually is a little bit difficult to delete the data. In order to successfully delete the data completely, you have to delete it from every single peer before that peer can resynchronize with another peer. So you basically have to wipe everything all at once. And there's a good reason for this, is if you do delete the data, it's possible that one peer might have deleted the data, and another peer might still have a copy of that data. So when they both come back online, you get corrupted data. You get conflicting results. The way I like to explain this at a high level is, can you remember, can you forget the last birthday that you had? Can anybody forget a specific memory that they had? Anybody? Does anybody have the power of just deleting their memories? You do?
Sometimes.
OK, so sometimes you forget things. OK, but can you specifically say, ooh, I want to forget the last lecture I watched? Can you do that?
Sometimes.
Sometimes. Wow, that is
Alcohol.
impressive. Or through other negative substances that might corrupt your memory. So I like to state that Gun works like the brain. If you want to delete something, you forget about it. You can't just tell the system, oh, delete it. You just move on to other data, and it eventually gets forgotten. And yes?
So what if we have, let's say we move the data file to some other location, and the peers are not updated with how does the sync work then?
Yes, so that's a good point. So Gun will still work if you go through the subway and get disconnected. So if you go offline and you make updates, when you do come back online, the data will reconverge. So obviously, if you're offline, the peers can't connect and they can't sync the data. But once they do get a connection, they're able to sync the data. And because it runs through the same conflict resolution algorithm, they all wind up agreeing upon the same data. Does that answer your question?
What I'm saying is, let's say that like you deleted the one master file, whatever you had.
Yes.
And then before doing that, you moved it to some other location.
Yes, yes.
Okay, now you deleted it and you shut down the server as well. Then how will, so doing this, restarting it will create the same database in here, and how will it be syncing with the copies? That's what.
Right. Are you asking how did the server regain the data
Yeah, and also how will it sync with the new database? That's what.
with the new?
Yeah,
Oh,
because
with the
we copied
new
it,
database.
moved or whatever.
OK. So I'm going to answer the specific example what just happened. I turned the server off. I deleted the data. So let's imagine I then spun up a new machine. The way that it got the data back was from the browser tabs. So when the browser tabs connected with that new server, they exchanged the data that they had, and then they ran it through the conflict resolution algorithm. So does that answer it? OK, maybe not.
Okay, what I'm saying is, let's assume that we copied before deleting
Yes.
to some other.
Yes.
From C to D.
Yes.
From drives. So I want it to be synced with the D drive now.
OK.
How will that happen? Shut down the server as well.
Can you what?
Uh,
I'll try and can I talk to you afterwards? And I would love to answer the question. I'm not quite sure. Ultimately, at some point, people have to talk to each other. if they don't talk to each other, then you can't sync data. But I'll try and help you out with that afterwards, because that could be an important question. All right, let's jump into actually getting started with Gun. So there's two ways you can get started with Gun. You can either, if you're a front-end developer, you can just use that server that we went to earlier as the relay server. However, if you are a Node.js developer, you can also download Gun to your machine. So curiosity, how many people here have Node.js installed on their computer? OK. All right. And then of the people who do not have Node.js installed on their machine, are you guys, so raise your hand if you're front-end only and have never dealt with a backend. OK. So about two, or a couple. Now raise your hand if you are also a backend developer, but you just aren't Node.js. OK. All right. So by majority selection, I'm going to go into some of the Node.js stuff, but then I'll try and zoom out and approach it from a non-Node.js perspective. So first task, everybody open up your laptop and give me some traffic. Go to gundb.io, just because that's easy to type, which is this URL right here. And once you're there, click Fork Me on GitHub, which will take you to the open source repo. Now that we're here, there's two options. Either, so how many people are on Windows versus not Windows? OK. So not very many people on Windows. OK, Windows. All right. So if you do have NPM, and so if you have Node.js already installed on Windows, NPM is included on it. So it should be as simple as pulling up the PowerShell and let's see if I can just do this myself, and typing npm install gun. That will start downloading Gun. For all Windows users, is that working? Don't be shy, because this is going to be hands-on, getting people to get started. If you are on a non-Windows system and you also have Node and npm, you can type in the same thing in the command line, and it should work. Do you need help? OK, that's fine. Is anybody having an issue at this point? Or are we all good? So I'm going to assume that we're doing well so far if nobody's raising their hands. And please don't be shy about raising your hand if you're having an issue.
Do we have to install it first? Do we have to install it first?
So if we're going the Node.js route, then you do have to download Gun to your computer. However, if you don't have Node.js, we can also use Gun from a non-Node.js perspective. But I want to hit the Node.js side first, and then we'll move into the not Node.js. So once you have it installed, and if you want to run the same thing that I did, you should be able to see that there is, whether this is Linux or Mac or Windows, if you have npm and Node.js, that when you did npm install Gun, it should have created a folder called node modules. Is this large enough that people can read? I guess it's at the bottom of the screen, which is bad. OK, I'll pull it up. Oh. So if you cd into node modules, you'll see that Gun is there. And you can cd into Gun. And that's the repo that you see on GitHub. Who's at that point currently? OK, you are, and nobody else? Where you are at that? What point can somebody throw out where they're at right now? Who's not here? OK, should I go over the instructions? So you go to GitHub, or if you have npm or Node.js install, you go to your command line, and you type in npm install Gun. And that should pull the project repo down into your computer. Doing good? Yep.
So do we need Node.js and NPM?
OK, so have you already installed Node.js? OK, so Node.js should come with npm pre-installed with it. When you type npm, does it throw an error or does it work? Yes.
I just installed Node.
OK. So you just installed Node and you're still getting an error?
Yeah.
OK. How many other people are getting a similar error? OK, you back there. OK.
Oh, it worked.
OK. So you got it to work. What did you do to get it to work that it didn't throw an error?
Oh, I just restarted the CMD.
You restarted what?
I just restarted the terminal.
OK. He restarted the terminal. An error? OK. What is the error? npm. OK. I don't usually recommend this, but do sudo npm install gun. All right. So for the people who do have it downloaded, go into cd node module /gun, and when you're in that repo, go into cd examples, and then I'll catch up with other people who are getting there. Run node examples, node express JS 8080, and that will launch the example app that I had before, which when it turns on. Oh, sorry. Actually, one piece of information. Express is not included in Node. So you probably, in the examples folder, also need to do just npm install. How are we doing? So if you run npm install, it's going to then install Express. You don't need Express for Gun, but how many people here use Express or have used it before? OK. Not too many people. So how many people have the example app running? 1? OK, 2 people. All right. So for the people who have not gotten to that point, OK, 3 people. You, sir, over here. Where are you at?
Blank screen.
Blank screen. Did your laptop die? OK. While we're working on that, I'm going to move into the front-end only side of Gun. OK? And then hopefully we can get some of the Node.js stuff up to snuff in the meanwhile. So I'm going to open up my favorite editor of Notepad++. And I invite everybody who's not trying to go down the Node.js path, people who want to focus on front-end development only, to pull open their code editor as well. Do we have our code editors open? Yes? I need to start cracking jokes or bringing in kitten memes. So we're going to type some HTML to get this app started. HTML. And of course, we're going to add a body. And we're going to say, hello, world. OK? Not super interesting if you've done HTML development before. So we're going to build just a small, quick app with Gun. So we're going to do this. You will need internet connection. So how many people here have internet connection? OK, good. We're doing well in that department. So type in http://gun.js.herokuapp.com/gun.js. So that's going to pull in Gun source code into your browser, while if you're taking the Node.js route, you're pulling in Gun source code down to your computer. So both ways are going to work, but they're just approached differently, whether you want to run your own server if you're a backend developer, or if you're a front-end developer working only in HTML. So obviously, if you're a front-end developer only, and you are going to use Gun, if you're going to be using Gun, you're relying upon My Heroku app to deliver that to you. And that's not necessarily always the best thing. But in the case of you just want to get something done and it to work, it's a great way to go. But for the more advanced developers who do run their backend, then you're going to want to run your own server, which is exactly the same thing as the Heroku app. It's just on your own machine. So how far are we with this setup right here? Yep. Yep. Is anybody struggling with the HTML only side? The front end? Nope. Don't be shy. We're here to help each other. Remember, this is about making things easier, not about talking about stuff and then pretending like you know it when in reality nobody actually knows how to do it, and then none of us get anything done. So does anybody need help with the HTML stuff so far? No?
Saved in the same directory, right?
Oh, so for Node.js, the Node.js route?
Yeah.
So if it's in the Node.js route, yeah, all you have to do is script source equals gun.js, and the server will automatically deliver it.
Is there a tutorial on this, like for people afterward?
There should be. And as a solo developer, I am working on that, and this video is going to be a great way to start with it. But yes, I will be getting a tutorial for people, but right now I am the tutorial. So does anybody else need help so far?
Wait, why did you just include GunJS locally?
That's if you're running. Yeah, sorry. OK, I'll just delete that. So if you are running your own gun server from your own machine, then you can just include it directly rather than from Heroku. All right, I'm going to assume that we're at this point, and we're going to get started. So the first thing we need to do is we need to initialize gun. That sounds a little scary, but it winds up being as simple as this. Capital G gun is the global namespace for gun in the browser, and everything is contained within inside of that. So we're just going to do var gun, lowercase gun, or you can call it whatever you want. You can call it kitten or happiness or Fred. This is going to be your database that syncs. And then you call capital case gun to initialize. And you're going to initialize it relative to some peer. In the case of front end only, we're going to initialize it, well, with the peer that we pulled the source code from, which is Heroku. And that is by doing http://gunjs.herokuapp.com/gun. Note that is not gun.js, but just /gun. If you're running it locally, then you'd be doing something like this. Oh, that is whatever port you're running on /gun. OK, so if you're going a local development route, that is how you do it. So basically, you're telling gun, this is a peer that I want to connect to. Now, yes, in this situation, it happens to be a server peer. But because gun is entirely decentralized, quick question, how many people know what WebRTC is? OK, so one person. I am not going to go down that route then. So how are we doing so far with this? OK, now I'm going to pause for a second. The Node.js route, how are we doing? Have people been able to recover and get NPM to stop throwing errors? Or did people just abandon it? So if you abandoned it, raise your hand. OK, so 3 people abandoned it, or 4 people abandoned it. Who's still running localhost version and got the npm install gun to work? Oh, wonderful, wonderful, wonderful. OK, so maybe I should keep the localhost. I'm assuming you're going to run it on port 8080, but adjust it as you want. OK, so or let me get syntax highlighting here. Actually, I'm probably just going to save it as to my desktop as yay.html. That's always very descriptive. So the commented out stuff is for local, the people who got the Node.js route, which would be this. All right. Am I going too slow? Am I going too fast? Do you guys want lots of money? Okay. Do you guys want candy bars? Oh boy. Okay, so now that we have Gun initialized, we're going to tell Gun that we want to save some data. So it's actually as simple as doing gun.set, calling that function, and passing in a JavaScript object like hello world. Okay? And Gun will just save that for us. So just gun.set, hello world, and we're done. Not too hard. Okay? So we initialize, well, so we include Gun, we initialize Gun, and we then save some data. Now, I mentioned that it's easy for our brains to forget stuff earlier, right? If you just do gun.set and you save this hello world object, you'll forget about it because you don't have any way to reference it. You don't have any way to remember it or to recall it. So the way that you do that is you create a key for it. In the same way that you have a key to your apartment or your dorm or your house, a key is a reference to your room. So you do gun.set, the thing that you want to save, and then .key, and you call that function, and you pass it a string of whatever you want to call it, like my candy bar. I don't know why I'm calling it that, but it works, yes.
So when you do .set without the .key afterwards, it doesn't throw an error, so what happens to it?
So if you do what? Gun.set without .key afterwards?
Yeah, it doesn't throw an error, but what happens?
Yeah, so if you do gun.set, you're basically telling Gun, oh, I want to manipulate this data right now, and I'm going to do stuff with it, and it's going to get saved, but you don't care about remembering it later.
It's possible for you to get to that data afterwards.
In one of the new features I'm adding coming up, you will be able to get that data back, because that was a problem that people had. But generally speaking, sometimes you want to remember data, and sometimes you want to manipulate data, but not remember it.
But we have to make our own keys.
Yes.
Yeah.
For now. But you don't have to make a key for everything. We're going to get to that in a minute. So you just have to have a starting point for your data. So let's say you have a house. You need to enter in through the front door, and you have a key to enter into the front door. Once you have that key to get in the front door, you can explore the rest of the house. You can go to the different rooms. You can go upstairs, downstairs. You can go out the back door, whatever. All right, so now we've done gun.set. We, of course, want to get the data back, right? So I'm going to do it the more explicit way in terms of I saved a reference to my data, and sometime later I want to load that data again. So, but there's a couple ways, but we're going to go over this. So we do gun.load, and you pass in the key that you want to remember. So you're loading that key in. So this is a very basic key value. My candy bar, okay? And then you do .get, and you pass it an anonymous callback function. And the value inside of here is going to be the thing that you saved. So console.log value. All right, now we have a complete app, at least for a quick demonstration purposes, but hopefully we'll get into more exciting stuff. This goes till 5:30, right? Yes, 5:40. Wonderful. All right, I'm going to save yay, and I'm going to run it. Open up the browser. Hopefully I won't have any fail to load resource. Oh, that's because I forgot to actually comment out the Node.js path. OK. Yay, it logged out the data that I had saved, which is hello world. Okay. Now if I let me comment out this line so that way it doesn't save it again. Okay. I'm going to refresh the page, so it's not going to resave the data. It should load the data from before, and sure enough, there it is. Okay. How many people are on course with this and gotten this to work? Okay, a couple people. How many people are super excited about getting this to work and haven't gotten there yet? Okay. How many people are miserably bored but want it to work? Well, nobody's being honest. So that is simple key value. But let's do some more interesting things. You've already seen the real-time syncness of Gun, so I'm not going to go into that a whole bunch in this tutorial. Let's load some more complicated data. So rather than doing hello world, let's pass in something you might pass into MongoDB. You might say like, oh, we have this person named Fred, and Fred itself, or himself, or whoever Fred is a sub-object. Let me make this look pretty, so that way people can understand what I'm doing. And Fred has some values, like age, 36, gender, male, other pieces of data, like, I don't know. Let's start with that, OK? And then we also have another thing, like Carly. And her age is 29, gender, female. OK? So now we have data, and we're not going to save it to my candy bar. That sounds odd. People. Actually, I just realized this is getting saved to my server there. So I'm going to prefix this with something to not mess anything up. I'm going to be like HackingEDU. And by the way, if people are using the, if you guys are using, okay. If you guys are following this verbatim, it is going to be syncing with my computer, and it's going to be overriding some of the data. So when you make the key, do like HackingEDU mark, okay? So that way we're not. Has anybody had that problem? Okay. So it would actually be syncing. I'm glad I caught that before getting into it. Okay. So now I'm gonna comment out the load part. So that way, what I'm going to do is just save the data to begin with. I'm going to refresh. Was that a question? OK. I'm going to refresh. We don't know anything happened because I didn't log anything. I'm going to comment this out, and then I'm going to uncomment this. And I'm going to copy the key so that I can load it. And what is about to happen might be a little confusing. So we're saying, hey, gun load this thing and get the value. When I refresh, there it is, object Fred, Carly. But, da-dun, da-dun, if you click it, you think, OK, this looks all right. But if you click it again, what? What just happened? Where did my data go? It's this weird thingy. What happened to that? Well, that's because the way that Gun is handling all this magic for you is it has to make universal unique identifiers to every single item that you've saved. So that way, at the machine layer, it's able to actually synchronize the data without getting confused. But the human doesn't like this stuff, so what do? Well, we just throw in the sweet thing called dot. So rather than doing .get, we're going to do .map. And .map is like for each. What I was going to say is load in this object, map or for each over each item, and give me that item itself. So in this case, we're going to have the person and the field name that we saved them with. So person, field. So we're going to log that out. And sure enough, we get our objects back. So you might think, oh, this is a little strange. Why isn't Gun giving me everything back at once? Well, the reason why Gun is so fast is because it's using partials. So it only synchronizes, so it synchronizes the data as fast as it can in as small of subsets as it can. And then it slowly accumulates that up over time. So who here has heard of React from Facebook? OK. So part of the reason why Facebook's React engine is so much faster than Angular, well, Angular 2 just came out, so there might be some competition there, is because React uses partials when it's updating the DOM. So as a result, it's not reformatting the entire page again. It's just changing that one element. Gun's doing something similar, so it's really, really fast. All right, now we're going to get a little complicated. So far, you've seen that it does key value data, that it does MongoDB-like documents. But I might have mentioned earlier that it's a graph database. What does graph even mean? Well, this is something I'll just show you. All right, so I'm going to abandon that thing. Or how are people doing? Doing all right? Doing what? You're not able to type as fast? Or?
I'm not able to keep up with you. Sorry.
OK. I'm more than happy to sit down with each of you guys individually afterwards and make sure that if anything didn't work, make sure that it does work. So rather than saving the gun directly into Gun, rather than saving the data directly into Gun, I'm going to first create just some regular old JavaScript objects. So blah. So we have Fred, who actually no. Let's call this object Fred. Age. I'm going to have a different age so we know we're dealing with different data. 31. Name, Fred, gender, male. And then we're going to create another just regular old JavaScript object of Mary. Actually, Hannah. And age, 32. Name, Hannah. Gender, male. Or, oh, man. That is bad. Now we're going to do something as follows. Fred.girlfriend equals Hannah. All right. And of course, we want to save this back to MongoDB or our document store. So we got to convert it into JSON. So we're just going to use standard JSON dot stringify Fred. But we forgot about something. We want Hannah.boyfriend equals Fred. There we go. That's right. All right. We're golden, right? Can anybody predict an error that might happen? Circular references? Yes. And I'm going to show that in full glory. All right. So when we run this, we're going to get an uncaught type error, converting circular structures to JSON. Who has encountered this before? Only 2 people. Oh, well, OK. It's not going to be as cool that if nobody else has encountered this problem. So basically, if you're using MongoDB or one of these other document-oriented databases, they cannot handle data that circles into itself or has relations to other things, or that thing has a relation to the thing which is itself. It gets really confused. So unfortunately, I guess people haven't had that problem other than 2. But I'm still going to go through it because it's really, really awesome. So usually, it's going to throw an error. But if we save it to Gun, so gun.setFred, OK, .key, HackingEDU, mark, Fred. So in this case, I just created a key that points directly to Fred. Let's do gun.load. Same thing of Fred. We're not going to map over it, though. We don't want to map over Fred. That would hurt him. So we're just going to get Fred. And make sure that that's fine. So we're saving Fred to Gun. But so I'm going to run that. And if I typed everything correctly, we don't get any errors. But I might have mistyped Okay, let me double check something. Okay, so we got Fred back. And Fred is that previous Fred who has a girlfriend, which, again, is that scary thing, which, well, not the girlfriend's not scary. The reference to Fred's girlfriend is scary. So what if we want the girlfriend? Well, all we have to do is gun.load the reference to Fred, the key, and we can do .path. So we're going to path into the field on Fred. The field that we're interested in is girlfriend. So we're just going to type in girlfriend. Actually, let me make this a little bit prettier. Oh, I'm married, by the way, so I'm very happily married, and I'm not trying to, in any way, shape, or form.
By the way, your name is Fred, and Hannah was very nice.
So, is there a problem?
No.
Okay. All right. Oh, okay. So we're doing, hey, gun, load this reference to Fred. And then navigate. So you can imagine you have the key to open up your house. And then you want to navigate upstairs. So we're going to say, oh, go up the stairs to this other item, such as girlfriend, this other person as girlfriend. And then if we save this and rerun it, we then get Hannah, right? But what if we want to get Hannah's boyfriend? Well, we could either do .path boyfriend again, but that's redundant, so why not just do girlfriend.boyfriend, okay? So when we save that and refresh, we get Fred now. Even though we loaded Fred, we navigated into the girlfriend, and then from the girlfriend, we navigated back into Fred. Yes?
That, go back to your code.
Yep.
That person object is the girlfriend, so you can do .path on that too, right?
So the person, so this is a plain old JavaScript object. If you do want to do a path inside there, it's jQuery style. This object is the gun object. So let's do that right now. That is a good point. So if I do just, this is a little bit more ugly, but if I do this .path, because this is a reference to the girlfriend now, and I do .boyfriend, and then I do another callback inside of this. This is where JavaScript gets kind of ugly.
So that's why you do it that, okay.
Yeah. This is going to be Fred now. So don't worry. That's why there's the other methods. That way you don't have to do this, right? So, right. So now you still get.
Yeah, that's right. That's right.
Oh, okay. Yeah. Hi, Fred. Right. So you can do it that way if you want. Sometimes you might need to do it that way, but generally speaking, it's just cleaner to keep things outside of that. All right, so now what you've seen is we can do some really, really fun things, but I want to do something a little bit crazier than that. Girlfriend.boyfriend.boyfriend.age. Yes. So if I run this, it gives me back Fred's age specifically, not the thing as a whole. All right. So that is graphs. They sound really confusing because it's like Inception style, where you have a dream inside of a dream inside of a dream. But guess what? Reality is kind of like that. Your data is messy. I know somebody who knows you, who knows me, and that's why people use relational databases. But then you're like, oh, I want to create this other new thing, and I don't care if there's the age field or not. And relational databases are like, what? You didn't create a table. So that's why then people all shifted over to MongoDB and NoSQL, because it's like, oh, it's really fast and easy to prototype and get up and running. But then they get up and running, and they can't do any relations. And they're like, what? And then they complain about Mongo, and then go back to Postgres. But then they start using Postgres, and vicious circle inside of itself. So I'm trying to break out of that circle and say, hey, if we just look back at our math classes, there's something called graphs. And graphs are mathematically the superset of relational data and document-oriented data, or trees. So Gun is a graph database. You get the advantages of both relational data and document-oriented data. And the upcoming feature that I mentioned will actually allow you to use SQL on Gun. You'll also be able to use MongoDB's query API on Gun. You will even be able to use other query languages. If anybody's heard of Neo4j, they have a special query language called Cypher. There's other programming languages, not programming languages, query languages called Link. All of these can be implemented on top of Gun. So Gun, sorry, just because it's mathematically gone the right direction, will give you the advantages of all these databases plus the real-time push notification built right into it. So at this point, that kind of wraps up a quick introduction to the vernacular and the usage of Gun. Where would you guys like to now move into? Do you guys want to go back to becoming a Node.js, going down the Node.js side? Would you guys like to go into more technical aspects of Gun? What would you like? Throw out ideas. Technical aspects? OK. Technical? All right. I'm going to jump over to so one last comment. Running Gun via Node.js is nothing special. Where you're pulling Gun from the server right now of Heroku is just it's the exact same server that's hosting the to-do app. Okay? So this thing that I just wrote is using that same relay server as the to-do app, as the JSON editor. So anybody can run a Gun instance on their machine or on a server and build as many apps on top of it, because that server-side component is completely agnostic to the app itself. So it literally is the difference between referencing it locally right here or referencing it from somebody who's already running one. The thing that I mentioned, WebRTC, when I get the WebRTC component working, you won't even need a relay server because the browsers will be able to connect and talk to each other directly. OK, so if you go back to the Gun page and head over to so some of this stuff just goes over what we did. Check out the wiki. OK, we're going to jump into the wiki. And in the wiki, I don't have enough documentation yet, so I really, really need to work on this. So that's why I'm here, to tell you in person. Partials and circular references goes over more of what we just did. But the technical stuff, conflict resolution with Gun, is way too jargony sounding. So I'm going to jump into, I should have, I had a link. I wonder if somebody modified it while I was, or maybe it's to some pretty slides. Here we go. Oh, no. All right, give me a moment. I'll pull it up. So while I'm pulling it up, what about the technical aspects are you guys interested in? The synchronization, in how the graphs work, in hit me with questions. How the graph stuff works. OK. So go to JSON data format in the wiki, and it's going to step through the format that Gun uses, which is going to look a little strange at first. We have a regular JavaScript object, and Gun is always going to attach an additional property, the underscore property. The underscore property is saying this is Gun-specific metadata that Gun needs to handle the conflict resolution or the synchronization.
So that's a reserved key.
It's a reserved key, yes, correct. Now, one of the items in that reserved key is going to be the universally unique identifier that points to this object by itself. Okay? And that is the ugly strings that you saw for the .girlfriend or the .boyfriend, or when you mapped over the object. Those are the pointers to that value. So that stuff looks ugly, and I use this reserved hashtag symbol to mean it's the soul or the identifier for this piece of data as it's mutated over time, as it changes over time. Now, it gets a little bit more complicated. This is going to expand, okay? Inside of this, this is a way for us to reference the vertices or the nodes within inside of a graph, where node here means a graph node, not Node.js. So everything is split up into that, and that's how the graph works, is it just says, oh, everything has its own universal unique identifier, and we just point to the thing that we're trying to find. And that's the graph side of the equation. When we're starting to get into then how do we deal with conflicts on that data, does that answer your question? So in technical terms, Gun normalizes the data into first form. I believe that is how they call it. In non-technical terms, if we have an object like we did earlier that is complicated, or not complicated, but is deeply nested, or whatever. And then we have Hannah again, who is this other object. Okay, that is nested. It's document-oriented. It has a tree to it. So you can put that into Gun, but Gun is then going to convert it into this ugly thing. So Gun down converts it into something that looks like this. Oops. We're really objectifying everybody here. I do not approve of it. So rather than having mother strictly as a sub-object of Fred, I take all the sub-objects and I flatten it into one object, which then have their individual properties. So let me type in age 16 again. And then, of course, here, rather than having mother be the thing itself, this points to FDSA, which happens to be the mother object. Does that make sense?
Literally do that.
So this is Gun source code. And this is the serializer that takes regular JavaScript object data and then creates a working environment of the objects that it's seen. It then recursively calls this function. It iterates over each property in the object, so Fred, Hannah, and then checks to see if it's a simple primitive value, like a number or a string. If it's another object, it adds that object to its seen list and creates a universally unique identifier for it. It then goes into that object and starts mapping over it. And then if it finds that there is an object inside of there that is one that it's already seen, then it knows it's a circular reference and then replaces it with the identifier. Else it just keeps on going until every single path has been traversed and the entire spaghetti of the data has been unraveled. Yes?
That's probably just a JavaScript language issue, but how do you store just the reference and not the actual object? Isn't it trying to pass it by value?
You just use the pound sign again, right?
Yeah, so how do I store the reference? Gun has a specific format for addressing that, which is an object of a single property, which is the hashtag, with then the identifier. So in this case, I'm going to delete this. It would look like okay. And then where the mother object, of course, name, Lucy, age 56, all of these objects have, the metadata property, which contains what their identifier is. So in this case, we replace the mother object itself. So we pull the mother object out, and we put it into a flat JSON object here. And then we replace what used to be it with the reference here that then has the ID that then points to this object on the graph itself.
Okay, so the child doesn't contain the reference, only the parent contains the reference to all the objects.
So that's completely up to you. So in the case of the girlfriend, boyfriend, girlfriend, boyfriend, girlfriend, boyfriend, we, the application developer, told Gun, oh, we only want that we wanted a reference both ways. Now, you might not always do that. Maybe you just start with mother, and then mother has a child, and then the child has that object, and that object has no pointer back to the parent. That's up to you how you want to model your data.
And regarding the random key that you generate, like
Yes.
FDSA is a random key. So is it a pseudo-random key or a totally random key? And how do you make sure that it doesn't?
Yes, good question. So it is just a messed up version of JavaScript's math.random that generates a random alphanumerical value of a certain fixed length. So that is the default implementation. You can configure Gun to use your own ID generator if you have more specific requirements. In my case, a 26 long randomly generated alphanumeric string doesn't usually have a collision rate with other things. But it's always better to be safe, so you can configure Gun to use a more strict form. Okay, I'm going to check how we're doing on time. 5:28, so we have another 10 minutes. OK, wonderful. Any other questions as far as the graph side of the equation? So the nice thing is you don't have to look at this ugly stuff here. Gun's handling that for you in the background. And the beauty of it handling it for you in the background is, you get Postgres combined with MongoDB. You get data that can be really, really flexible. Yes?
What happens when you synchronize a really large database with all of the clients? Like, surely they're going to eventually hit memory constraints.
Right. So let's take this object here, which has ASDF, FDSA, and I should modify this to be some JKA. All data. Let's imagine that everybody in the world used Gun. Google, Facebook, Gmail, not for my vanity purposes, but everybody used Gun. The idea of the graph with Gun is that no matter what service, no matter who it is, whether it's all contained inside of this one universally growing graph. Okay? Now, the reality is that people aren't going to do that, and people don't do that. So the way that it's modeled is that there's this universal graph that theoretically represents everything in the universe. Okay? And you right now only have this subset of the data. And it's valid to have any given subset of the data. It's just whatever data that you're interested in. So all the peers, if they so desire, can hold the entire graph in it. But realistically, because of storage constraints, memory constraints, you cannot. And that is then where, in the protocol, Gun has to allow you to only have a subset of the data, or else Gun won't scale and it won't work. So does that answer your question? Peers?
How much do you want to have?
So right now, it's as your memory usage increases, you run out of memory, and your app explodes. But because it's using Gun, it just restarts, and it's back to fresh.
But then won't it start pulling from somewhere else and start exploding?
Yes, going up again. So right now, I haven't written any means to detect the limits of the system and then intelligently get rid of old data. That is a very, very vital piece that I need to add, which is why Gun is not production ready yet. So Gun cannot be production ready yet until I get that piece to make sure that the app doesn't crash and then restart. Now the nice thing is, like, even if it does crash and restart, that's actually not really a problem. You just go back to zero memory. So in almost because I designed Gun to survive crashes, it almost works in your favor, but obviously you don't really want a crashing server, so I'm going to make sure it doesn't do that, that it does handle its memory.
Does it really just store everything in memory? Is it store anything on disk?
So the actual storage or persistence layer is a modular plug-in adapter. So I've written one specifically for local storage in the browser, which has a 5 megabyte limit. One of my friends wrote a, for Node.js, it just saves the entire data to just a single file. And don't use that in production, but it's nice for testing in development environments. And then the one that I wrote, which I'm interested in using, is it backs things up to S3. And that's the one that the Heroku website is also doing that. So that way, when in 15 minutes, the Heroku destroys the server, and let's say everybody else leaves the Heroku website so that there's no peers remaining to store the copy of the data in the browser, there's still a backup on S3. So Gun will basically write to a storage layer when you hand it a storage layer, whether that's local storage, whether that's disk, whether that's S3. And they're pretty simple adapters. So I need to write one for Google Cloud Storage. I need to write a more robust file system one. Those are just components that you can add and configure. So that's up to you. You theoretically could have Gun run entirely in memory. But the whole point of Gun is to not lose data, so you probably don't want to run it entirely in memory, or else you risk losing it. All right, so questions answered as far as the technical aspects of the graph. I highly recommend, before I move on to one of the things or just wrap up, the semantics page on the wiki. It breaks things down into kind of the vernacular that I use because, well, Node can refer to a graph or it can refer to Node.js. So that can get confusing. So I just have a specific vernacular for explaining stuff. In the case of the data itself, it's reduced down to a value, which is a Boolean, a string, a number, or a relationship, a field, such as age or girlfriend or mother, and a node, or an object, is field value pairs. So when you have a bunch of field value pairs, you get a node, which basically to us just looks like a JavaScript object, right? It's just JSON with, here's an object, age, mother, values. So value, that is pointed to by a field. And then there's a bunch of fields inside of a node. And then that node has a universal, unique identifier called a soul to track it over time as it grows and changes. And then that soul or that node exists inside of a graph, or the graph. And the graph is basically everything in the universe, but you might only have a subset of it. So that's all the pieces in terms of the data. With those, like value, field, node, soul, graph, with those like 5 concepts, you pretty much cover every possible edge case of data, whether it's relational, whether it's document-oriented, whether it's key value, whether it needs to be synchronized, blah, 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 blah. So it's a pretty powerful mechanism. OK. So at this point, are you guys all hungry and just want to get back to food? Or in the last 5 minutes, would you guys like to go over some other technical detail? OK, sounds like food. All right, thanks so much. And please, please, please let me sit down with each of you and get the Node.js one downloaded. So that way I got stats going up and I can be happy and track stuff. So let me know. Thank you.